Hey guys, so far we have learnt about 3 congruence rules. SAS, in which two sides and the included angle of one triangle are equal to the corresponding sides and the included angle of the other triangle. ASA, in which two angles and the included side of one triangle are equal to the corresponding angles and the included side of the other triangle. And lastly, AAS, in which two triangles are congruent if any two pairs of angles and one pair of corresponding sides are equal. Now let us solve some problems based on these congruence rules. So here is the first problem. In this figure, PR and QS are equal perpendiculars to a line segment PQ. We have to show that RS bisects PQ. So here it is given that PR is equal to QS and PR and QS are both perpendicular to PQ. So angle RPO is equal to angle SQ and they both are of measure 90 degrees. Here we are asked to show that RS bisects PQ, which means RS divides PQ into two equal parts. So mathematically we can write it as PO is equal to OQ. So consider the triangles RPO and SQ. We already know that PR is equal to QS and angle RPO is equal to angle SQ. Are there other measurements which are equal in these triangles? Look carefully. Angle ROP and angle SOQ are vertically opposite angles. This means they are equal, right? So angle ROP is equal to angle SOQ. Now what can we say about these triangles? Here there is one side which is not included between two angles. So by angle side or AAS rule, triangle RPO is congruent to triangle SQ. Since the two triangles are congruent, by CPCT, PO is equal to OQ, or simply RS bisects PQ. Hence proved. Great. Now let us look at another problem. So here it is. In the figure shown, PQ is equal to PS, PR is equal to PT and angle QPS is equal to angle RPT. We have to show that QR is equal to ST. Consider the triangles PQR and PST. We already know that PQ is equal to PS and PR is equal to PT. Do we have anything else? Yes, it is angle QPS is equal to angle RPT. But we need angle QPR and angle SPT to prove the triangles congruent. So let us add angle SPR on both the angles. So we get angle QPS plus angle SPR is equal to angle RPT plus angle SPR. Now angle QPS and angle SPR together form the angle QPR and angle RPT and angle SPR together form the angle SPT. So we have angle QPR is equal to angle SPT. Thus, in triangle PQR and triangle PST, PQ is equal to PS, PR is equal to PT and angle QPR is equal to angle SPT. Thus, both the triangles are congruent by SAS rule. And once again, we will use CPCT, that is, corresponding parts of congruent triangles to show that QR is equal to ST. Hence proved. Now, before winding up the video, let's solve one more problem. In this figure, Y is the midpoint of XZ, angle BXY is equal to angle AZY and angle AYX is equal to angle BYZ. We have to show that triangle BXY is congruent to triangle AZY and BX is equal to AZ. It is already given that XY is equal to ZY as Y is the midpoint of XZ and angle BXY is equal to angle AZY. We have to find one more pair of corresponding parts to prove that both the triangles are congruent. What can be that pair? Let us find out. We know that angle AYX is equal to angle BYZ. But we need angles AYX and angle BYZ. So, add angle AYB to both the angles. Now, angle AYX and angle AYB together form the angle BYX. And angle BYZ and angle AYB together form the angle AYZ. So, angle BYX is equal to angle AYZ. Thus, by ASA rule, triangle BXY is congruent to triangle AZY. Now, as we know that the corresponding parts of congruent triangles are equal, BX is equal to AZ. Hence, we are done with the proof. These were some interesting questions, right? So, practice more questions based on what we have studied till now. And in case of any doubt, watch the videos once again. Now, it's time for me to leave. Goodbye.